Hi everyone and welcome. I'm excited to be here today to discuss a major milestone for the MySQL and Kubernetes community. Just recently, we announced the general availability of the new Percona operator for MySQL, which officially brings native MySQL Group Replication supports to Kubernetes. Today, I'm joined by two of our experts who were key to making this general availability release happen, Marco Tusa, our MySQL Technical Leader, and Ege, a senior software engineer on the cloud team. Marco, Ege, welcome. Thank you for taking this time to join our community office hours. Let's start with you, Marco. Could you quickly introduce yourself and tell the audience a bit about you and what you do at Percona?
Yeah, okay, thank you, Edith. So, Marco Tusa, I'm the tech lead in MySQL tech lead in Percona. What does it mean? I actually work as a bridge between the general service, so the part related of Percona that is working closely to our customers, and so the standard operation like support and managed service consulting and engineering. So I am more focus on how to use the tool that we are actually developing. And that brings me to interact a lot with people like Ege to, say, hey, this it's not working exactly as I'm expecting, or we should try this, or we should try that. So it's a really hands-on work from one side, and on the other side is a lot of discussion and preparing and planning with the engineering and also with my part of support. So it's a bridge. It's a mainly a bridge between two different worlds.
Amazing. Thank you, Marco. And Ege, please tell us about your role on the cloud team.
Yeah. Hello, I am Ege Güneş. I am the senior software engineer in our Percona operators, and like my team maintains our four operators, like MySQL, this new MySQL operator, our Postgres operator, and Mongo operators. So I am the software engineer, and like I am responsible for writing code mainly, and also understanding what is the technical requirements of the features we want to add, communicating experts like Marco to see what is the best way to do something with databases on Kubernetes.
Amazing. Thank you again. Okay, so before we dive into the technical details, some of you could set the stage for the audience. What exactly is this new operator, new Percona operator for MySQL, and what does its general availability means for someone running their transactional systems on Kubernetes?
Do we want to split? And you correct me if I'm wrong. I will cover the what is this, difference between the operator, and then you will cover the general availability concept.
Sure,
Ege?
yeah.
Okay.
Sure.
And I mean, I am going to say this from my perspective, right? Then Ege maybe want to say this from his perspective. So um, we already had developed long time ago, and we still actively maintain and advance the PXE operator, right? Which is based on a different technology that is Galera. But our customers and the users outside were asking us, okay, what about the other way of replication that exists in the MySQL world? Why you guys are not supporting them? And this was more an external, the debate: should we or should we not? At the end, we say, okay, let's do it. Actually, the guys takes a huge effort on building that, because also, if it looks like similar, is a completely different model to work on. And what we have done is mainly to focus on having the group replication implemented, and also the asynchronous replication implemented. Those are, we will see later on, right? But these are completely different words, because one is virtually synchronous, the other one is completely asynchronous, and answer to different business needs. So the main reason why we have done that is to have a complete scenario to cover all the different possibility that we have, from the MySQL side. Again, sorry if correct me if I'm wrong and add
No,
whatever you want.
this is like completely true. So like my team in Percona was developing PX operator, Percona XtraDB cluster operator for a long time, and it's a battle tested solution. Galera is very well known, and our operator is also very well used in various enterprises and with customers. But like we want to cover the other technologies, especially group replication is a new thing. It was coming in recent years, so we want to cover this also, and we are working for this operator for last 2 years. So it's new, yes, but it's new is like 2 years old right now. So we are working on this for 2 years to make sure it is ready for production usage. Yeah.
And GA here means, production
GA,
production
yeah,
available.
yeah, GA means generally available. So GA means that right now we are confident with this tool, with this product, that like we can offer our users, we can suggest our users to use it, see if this new product, this new operator solves their problems. So GA means we are confident with it.
Amazing. From an engineering perspective, what were the biggest challenges in making this grow replication stable and reliable between this dynamic environment of Kubernetes? We can maybe dive into the technical aspect.
May I interject before we go ahead?
Yep.
Because he said, we are correctly said 2 years working on this,
Yeah.
right? And the problem is that let's put is of course it takes time to develop something like an operator for group replication and for MySQL using, but at the same time we have to say that group replication is consolidate the technology consolidate a little bit, right? Because that is another aspect. Group replication is not new, but at the same time had a lot of weak spot, let's put in this way, that makes the utilization of this technology in the Kubernetes environment extremely challenging and sometimes also impossible. And that has delayed a lot the GA version because the technology itself, from the starting point, from the or code originator, was still having a lot of, let's say, shadows that now are almost fixed, mostly fixed. Sorry. Then I think
Yeah,
it
also,
was important to mention this.
yeah, also we need to mention that okay, we are working on this for 2 years, but it doesn't mean that like these 2 years the operator wasn't ready. So you could deploy group replication on Kubernetes using the operator maybe 1.5 year ago. But after, so just setting up the group application and putting on Kubernetes doesn't solve, like, fix all the problems. Then we need to do testing. We need to see the performance. We need to see what is the resource utilization and stuff. And also we need to cover this operator with a lot of tests. So this kind of stuff takes time rather than writing the code. Writing the code might be the easiest part of creating a new product. But understanding like, what is the behavior of this particular technology and understanding what is the bare minimum that we need to achieve and trying to achieve that is the biggest time consuming stuff.
Yeah, agree. So as you mentioned, Grow Replication were ready like to work 1 year ago, and you get a lot of feedback from the community. What kind of feedback did you get when they were testing?
Well, like there were some community members who were some early adopters, and they were trying and like asking some like not features, but minor improvements. Okay, can I configure this, or I want to behave this operator behave like this and stuff. So mainly they were either creating tickets to our ticketing system in Jira, or creating GitHub issues. So we talked a few of them. Also, in the beginning, there were some uh, big customers of Percona were interested. So we also like listen them and try to understand why they want to have this native MySQL operator on Kubernetes.
Yeah, the results at the same time, we also identify some issues that we have escalate to our, to the code producer and that they had to fix in order to have a more stable version to be utilized in the
Yeah.
operator.
I also remember, like in the beginning, there were a lot of interest about semi-synchronous replication,
Oh,
and also we added support for semi-synchronous. Then Marco like did a testing on semi-synchronous, not just on Kubernetes but in general. So I believe he has a very detailed blog post in Percona blog. And then we decided, okay, semi-synchronous is not something we want to have. Is not something we want to maintain because it has a false premise and we don't feel confident about it. And we decided to drop the support, for example.
And what is semi-synchronous? What is the difference between synchronous and asynchronous? And what exactly is semi-synchronous? To give more context to our audience.
Yeah, Mark.
I go? Okay. Let's make it very simple. Semi-synchronous acknowledge the fact that the package has been sent from the primary to the replica at different stage, right? While synchronous actually wait for the package to be certified. So it's a different level of of package shipment and certification. That in semi-synchronous doesn't really happen. The certification is only sending the package and eventually get back the acknowledgement that yes, I got the package. And the mechanism on the semi-synchronous has been certified that is not working as expected, and very often whenever it has problem, it rollbacks silently to a synchronous replication. It never recovered the semi-sync. So at the end is a really in the environment of Kubernetes where you have to be sure that what happened is under control. You cannot have this kind of unpredictable environment, and that has been the decision. And the decision has been to drop it because of that mainly. Okay, it's clear or
Yeah.
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 Okay.
Maybe we can put Marco's blog to description also, so people if they want to learn more about this
Yeah.
problems,
We're
they can
sharing,
see.
okay, we
Yeah.
share the link of in the chat as well. I'm also curious how this term of replication in MySQL change in the cloud native environment. What is different? What the term itself, replication chain, or is the same?
Replication chain.
Yeah.
Well, it's not a different thing on Kubernetes or not. Replication chain means like you have multiple sets of servers that replicate from each other, and sometimes your replicas replicate from the primary, but some of the other servers can replicate from your replicas, and the others can replicate from the replicas of replicas. So this you can create a lot of different kind of topologies according to your needs. Right now, the new MySQL operator doesn't support very elaborate replication chains. The main focus is group replication, and there is this a single cluster that replicate from each other. And with like when we start working on async and make it generally available, and then continue working on it, it will be possible to set up this elaborate replication topologies. But it's a future plan because first of all, like a single topology should work well, reliably, and performantly, then I believe the other stuff will come.
Do you have some thoughts about that, Marco?
Well, we are going to dive into another aspect, which is at the beginning, let's put it in this way. At the beginning, when I have been asked to work with the Kubernetes environment and with the operator, I was really reluctant, right? And I didn't like it. To be honest, coming from the MySQL standard on-premises environment, also virtualization like virtual machine for me were something didn't like that. But then there is a very important concept about replication and about Kubernetes. The mental shift that should happen is that whenever a DevOps or DBA is going to deploy a database on premises, it actually deploys one node, which is normally the primary, and then several nodes that serve as read scaling or and eventually for high availability, depending the kind of replication technology you are going to deploy. But each node is independent at the end, right? You see each node and its use in a different way. When you start to use Kubernetes, and I know, Ege, maybe you have a different opinion here. I don't recall because we did discuss about this in the past. But when you deploy something based on Kubernetes, that doesn't matter if it's actually a Postgres or MySQL database, but when it's a database, you do not deploy a set of nodes. You deploy a service, which is a completely different mindset. So when you deploy a service, you are actually expecting to have this service up and running, which is what Kubernetes guarantee. Then what is behind the service, which is 3 nodes, 5 nodes, 10 nodes, it's going to be something eventually unstable in the sense that it could be put down and relocate and move and and start it up again, but the service will stay up. What is behind may change. So this is why it's very important to have first a very solid, robust, trustable environment for the primary service. Then you can create eventually additional replication parts with asynchronous replication or other methodology, if you want, that create chains of additional services. But you have to see the first deployment with the Kubernetes part as a single service, not as a set of nodes. You may eventually scale in reads because you can eventually, have 3, 5 nodes and eventually may scale, but it doesn't. This is not a guarantee. It could be that from 5 nodes you move back to 3, or for a moment you go to 4. So the important thing is the service. Then you have eventual scalability for some features, but it may be inconsistent. And then, okay, solid part, and then you have eventually you can build additional features like DR through asynchronous replication or something like that. And again, go for it. I saw that you were
Yeah. Well, I understand what you mean about this like set of nodes and service distinction, and I believe it's generally true. It's a good mental shift about Kubernetes on database on Kubernetes. But still, even if it's a service to the end user, for a DBA, it's still a set of processes, and this process is running on different nodes. With they have different data tiers. They need to replicate between each other, and when something goes wrong, it is still a set of nodes. But since in case of PXE with gallery replication, since this technology guarantees that this changes that written in one node replicated the other nodes, and failovers doesn't need to be very transparent to to user. In case of group replication also, once you have a good failover mechanism, that this failovers or the changing of the primaries doesn't need to be very transparent. But when the async replication comes into picture, this paradigm about the services will be very tested, because then everything is changed and you cannot just have a service. There will be really a set of nodes that behaves very differently.
Yeah, and I agree. In fact, there is where we also now we have challenge, right? Because the main challenge is whenever you have synchronous replication is exactly that. You may have under the second failover eventually, or inside the second failover, and data will be fully consistent, from one node to the other, because as we say, we are talking about virtually synchronous replication, which means that the data, especially if you guarantee, high level of how you say that data consistency, you will have the data exactly the same when you do the failover from one node to another. If you are using a synchronous replication by design is different. And yes, in that case, you will have that the primary node may be ahead several minutes in terms of the data respect to the other. So you must consider them as a separate node. And here we have the problem, right? We have the problem with the service, because you can see it, that the nodes are different, but at that moment you see the difference. The service is not 100% guarantee when you need to wait for eventually another node to catch up and be ready for at least serving the writes. Maybe able to serve the reads, but not the writes. Are we jumping here and there, or we are following a logical path?
Yeah.
We are
I'm trying to
discussing
follow.
our.
Yeah, I'm curious also of what parts of group replication require the most automation from the operator side.
Well, the biggest thing was bootstrapping the cluster, for sure, because like you are creating this database, then someone needs to create the cluster, and the other nodes need to join the cluster and stuff, and we have like really thousands of lines just for this, because like we didn't want a central authority like operator to manage everything. We want every database node to be able to join the cluster by itself, and also create the cluster if it's the first node. Because like otherwise, if operator is down or if operator is under maintenance, upgrading and stuff, all this like MySQL restarts or database restarts can have worse consequences, or like there will be delays when joining the cluster and stuff. So every node can join the cluster and understand the topology. This was the biggest thing. So like we used MySQL shell heavily, of course, but still there needs to be a lot of things that we need to wrap using MySQL shell. But creating the cluster actually is done by MySQL shell, and operate like the database node understands its topology, then joins the cluster using MySQL shell. But we have very like detailed code to wrap around this MySQL shell stuff.
Okay. Do you have some thoughts, Marco?
No, it's okay.
Okay. Okay. So next question, how does the operator ensure the group replication cluster recovers correctly after a pod restart or a Kubernetes rescheduling event?
Well, in general, we don't need to do much. So if it's just a rolling restart that you like, maybe you are changing the minor version of MySQL, or you are changing resources and then pods are restarting. So in general, we don't need to do much. Like we are before the shutdown, we are removing this node and it comes back again. It rejoins the cluster, and everything goes well. The biggest problem is if you lose the quorum, because like group replication needs to hold the quorum to ensure the cluster is healthy. What should we do if we lose the quorum? So that was one important stuff. And luckily, MySQL shell has some good utilities for this, because usually what you need to do, okay, you lost all the servers, so you don't know from which MySQL server you need to restart the cluster, because otherwise you can lose data, and we don't want that. And like you have 3 pods with MySQL, for example. Pod 2 can has the most up-to-date data, or pod 1 or pod 0. We don't know that, and there is no guarantee for this. So what you should do, okay, you need to start each server without this group application cluster. You need to go each one and see, okay, what is the latest GTID and what is the most up-to-date one after comparing all these transactions. But luckily, MySQL shell has some good utilities called reboot from complete outage, and if all your servers are up, so it does what I say. It connects, it checks, and it decides the node to start reboot the cluster from. So operator is just ensures, okay, operator understands that there is a full cluster crash. All like MySQL servers stopped very abruptly and at the same time or closely. And then it ensures that, okay, we need to start each MySQL in a standalone mode without forming a cluster. Then we are using MySQL shell to reboot the cluster.
Okay. Okay, that's good. Thank you for your answer. Okay. For people who are new, for people who are listening, what is Galera and what makes Galera and MySQL replication, group replication fundamentally different? And why this is crucial to support both solutions instead of just choosing one?
Well, Galera is mainly a library that is used inside MySQL to guarantee synchronous replication across several nodes. It is initially developed by the Codership company. And the difference between Galera and group replication, the main difference at the moment is that Galera has a concept of multi-master, which means that it is actively maintaining let's say we have three nodes as primary. So for Galera, there is no difference between node 0, node 1, node 2. Okay. While in group replication, actually group replication started the same way, then they realized they were having some data inconsistency and problems, so they make as default the single primary, and then they shift out from this multi-primary thing. What is the difference is that Galera has a very strong mechanism to guarantee the conflict resolution and the certification, which allowed it to have this concept of multi-primary. At the end of the game, it doesn't provide you any right scalability. So what we have chosen to do is to maintain one single node as primary to reduce the effort needed for the certification and eventually avoid brute force abort and something like that. So it will make the Galera replication more efficient. The difference in terms of how the operator is mainly this one, the two, and then we have quorum that is valid in some way in Galera. Is the mechanism a little bit different for group replication, but they also, so there is quorum from both sides. There is flow control from both sides. It's the one on group replication is a little bit more advanced because you calculate the statistics based on a time interval, while in Galera is more based on the existing queue of events. So there are these small difference, but in the final behavior, they behave very similarly, which is they try to provide you an environment that is aligned from the data point of view. So the transactions that you have on node 0 should be the transaction ID that you have on node 0 should be the same on all the other nodes. As Ege mentioned, it could happen that you are not there. Why? Because I was saying virtually synchronous at the beginning, right? And this because the final certification that happened, it doesn't include the apply phase. So you may have all the certification in Galera or group replication that are done, then the node, the writer is going ahead, the writing is going to be done, so it's certified, but it's not physically finished, right? And if a node, something happened onto the node, in that moment, you may have a node that has a different GTLD apply respect to the writer, okay, to the primary writer. So normally it's a matter of few transactions, like inside the second or even that, but it could happen. So it's not that like a synchronous replication where you may have hours of event lost, right? It's really small. Does that answer?
But is there a way to make it fully synchronous? Like, can I say, okay, until you apply to the disk, really, don't acknowledge this?
Well, you have way to enforce yes, and there are settings that normally we do, to be sure that is applied. But in any case, when you have this kind of corruption or on the node, it could be in the read log, it could not be in the, because it's written, but it's not flushed, right? So in any case, you may have to go to recovery phase.
I see.
What do you think, Ege?
No, this is
Okay.
this is the expertise of Marco. I cannot say anything. I can just ask questions about.
Okay. Maybe we can talk a little bit about the Percona community. What were the reasons Percona decided to support both Galera and MySQL? And what does it mean for people from our community who's using MySQL on Kubernetes?
Well, Percona is a leader in MySQL community. Percona is a thought leader also. And until now, in case of Kubernetes at least, we had, we are very knowledgeable about XtraDB, about Galera and stuff. And we only had this on Kubernetes as a solution. But Percona can cover everything about MySQL. So that's one thing about, okay, if group replication is matchy enough, stable enough that we can suggest our users, then we can put this on Kubernetes also. So this is one thing about decision. Also, there were some already existing customers of Percona who were asking for this. So that was one thing. Then it will allow us to innovate on these different fronts also, not just about XtraDB, not just about Galera, but also about replication, about async, about orchestrator with async. And we will have these innovations on these fronts also.
Yeah, amazing. As I said, we have different Kubernetes operators for databases. You can explore our GitHub repo and find all of them. But for you, Marco, what does it mean for the community since we announced it? We are we have Percona Operator for MySQL for GA.
Well, we have, let's put it this way. First of all, we have the operator for Percona server, not only PXE, Percona server, and yeah, with group replication and synchronous in it is in preview mode. What is exactly the asynchronous replication?
Asynchronous is tech preview right now.
A tech preview, right?
Yeah.
Well, as Ege was saying, Percona is leader in when we talk about MySQL, and Percona server is one of the is showing that. So it is for us is mandatory to cover the whole possibility and the whole different combination, right, of that exist with the MySQL and Percona server. So it is just in a way to give our users and customers the possibility to choose the preferred tool. And this is mainly the key for us. We never force anybody to use this or that, right? We want to give them the possibility to choose what is the best, what they feel more comfortable for them to use. For instance, personally, I prefer PXE because I have been working with it from the beginning. I love it. I think it's a very strong product, and it gives you, a very solid and robust environment. But group replication does exactly the same thing. And I know a lot of people and experts that has preference in group replication because they can interact and automate through MySQL shell a little bit better than they can do what they can do with PXE. So they prefer that kind of approach. Is really to give the users the possibility to choose what they feel more comfortable with, and that is for the synchronous solution. Then async is a different story.
Okay. Okay, let's talk about more about real world workloads, especially those demanding consistently and high availability, like transactional systems, for example. Will benefit the most from using group replication on Kubernetes? Oh, did you hear, as you mentioned, there were some community members who were asking for this. So what were these real world workloads or scenarios that we can share?
Yeah. Are we comparing with asynchronous replication here, right? So synchronous replication against asynchronous replication.
Yeah.
Okay. The difference is, of course, whoever required a high level, very high grade of high availability, we are talking about 5 nines, then they need to go with a synchronous solution. They cannot stay with the synchronous. And giving that, the only solution we were providing before was PXE based on Galera. Now we have also group replication that we fill up, the gap that was existing. And in terms of business, whoever has high availability requirements that can afford that, so that can have standard OLTP traffic, they will be the ones that probably will benefit the most from synchronous replication. When you start to have a more intensive write, maybe not really OLTP distributed, but more, let's say, small write, many small write that execute, very frequently, then this kind of operations are probably working better in a system based on asynchronous replication, because the mechanism do not require the certification at the end of each transaction, and that will reduce the load that instead exists with the synchronous replication, that reduce the load of and increment the speed. Let's put it this way, right? Example are, people, for instance, in telephone company that have to maintain the log of the calls, right? So this is a very small record, and you may have thousand millions of records per second, and that kind of write will be not good for synchronous replication, because that means that for each small write, the server needs to do all this certification, while it will go quite well with the asynchronous replication that just process it and go ahead.
What do you think, Ege?
Yeah, if you want a better write performance, for sure async replication is better. But on Kubernetes, it becomes a different story. Still, about the performance is the same. But if you have very frequent writes and you are doing it very thousands in every second, then it means that your replication lag will grow and grow with every second, because the
Yes.
replicas will try to get all this data from the network, then apply all this data to their databases and stuff. So there will be a bigger replication gap. So this thing is not special to Kubernetes. The same thing will happen on-prem with virtual machines. The same story. The problem is on Kubernetes, the failovers expected to be automatic. Also on Kubernetes, there is this tendency to think everything is magic and everything will be just work. It's not this, because yes, operators is very smart about the workload it operates. But it's still you still need to understand what is the thing you are operating, and you still need to understand what is the best way to do some stuff. Operator is not a magician that can just do this and okay, there is no replication gap, there is no there will be sub-second failovers and everything just works. It doesn't work like this. And on Kubernetes, so to ensure async replication, and why it's not GA right now, it is particularly this problem. You can now with the latest release, the GA release of the MySQL operator, the PS operator, you can use async. It will work, and it is tested also. But the edge cases especially about these failovers and the failover automations are not there yet for us to be confident about it. Because if you are a company who wants very performant writes and you want to write a lot of stuff, a lot of small transactions, then you will have a big replication gap, and then you will do something like just changing resources or changing a minor version of MySQL, or your worker node on Kubernetes will go down. There will be a failover, and then we need to decide, okay, which thing we want to guarantee. Do we want to have a faster failover, so the availability of the database service should be continued, or do we need to ensure data integrity? And at least for me, of course, it can change from the workload to workload, or for some companies. But for me, there should be no question about data integrity. But some people cannot handle that much of failover also while waiting this new primary to catch up. So this is a trade-off that we need to see, and we need to provide solutions for both cases. And this is why right now async is tech preview.
Yeah.
And here is where we start to not diverge, but have different point of view, right? Because I totally agree. Of course, asynchronous, but asynchronous design like that. By design, is impossible to have it consistent between primary and replica. If you go for async, it's because you have specific needs, which are the one we were, you cannot wait for a synchronous replication to act, and otherwise it will be the same, because if you need to have a chain of nodes that you were mentioning before, you need to consider your async as one single node that guarantee you fully data integrity. Then you can have asynchronous replication with a million of nodes below. Okay, so it doesn't, if you really say, no, I want asynchronous replication, is because you need that specific thing. But that comes with a technology design that is, you will never have full data in sync at a given time when there is high traffic in terms of write. It's by design, and there is nothing to do about that. There is an important distinction, by the way, to do here. When we have asynchronous, we have the replication, we have two moments. The moment of shipping the data from the primary to the secondary nodes, and the moment on the secondary nodes that apply the data. Okay, so normally the gap that exists in replication is in the moment of the apply, not in the moment of transmitting the data. You have some gap, right? So, but normally it's not hours. It's, the time of sending over the network, unless you have very crappy network. But this cannot be the case with operator. I mean, with operator, you need to guarantee anyhow to have a good network that connect the nodes. So when you have that, this means that the data is not visible on the secondary node, but is there. You just need to wait like this to have the backlog to be applied on the local node, on the secondary in case of failover. You need to stay there, wait, and eventually you will lose maybe 2 seconds, 3 seconds. The problem is that waiting could take 1 minute or could take 10 hours. You don't know, right? It depends the kind of queue that is generated on the local secondary to apply. You can eventually start to serve reads, but they are still read because they are based on the previous. So, and I understand when Ege say, yeah, in Kubernetes, everything is supposed to happen magically. I mean, the expectation is that everything is magically, but the fact is that nothing can nothing can happen by magic. And especially when you move to asynchronous replication in this context, in the context of Kubernetes, you need to be fully aware of what is. It's a matter of educating the people. The users needs to get well informed, understand the problem. They should not have problem to understand it because it's the same thing that they have on premises on Iron. And after that, you may decide where to go. But yeah, I mean, I understand that Ege focus is, I must ensure maximum data integrity and as fast as can data recovery when about it. But this is impossible. Honestly,
Yeah.
it's impossible. It's from customer point of view that they need to accept and adapt their application based on how the asynchronous replication is designed. It's a matter of design. It's not a matter of magic.
By the way, I am also curious about something. We were discussing this internally also. So in case of Postgres, we have async replication too. In case of Mongo, we have async replication too, and for a long time on Kubernetes. And we don't hear this kind of problems. Why in case of MySQL, this I understand the problem, and I understand the problem should be the same in the other databases also. Why, in case of MySQL, this is more prominent? Why we talk about this all the time in case of MySQL? Is it because in case of Mongo, the engine itself like handles it, or we trust Patroni more than orchestrator? What is this difference? It's not just about the nature of async, apparently. It's about the technology also.
I would really like to see how far is the replication gap in PG. I don't know Mongo enough, right? I don't know Mongo enough. I cannot talk about it. But replication also in Postgres is when you use asynchronous, it needs to be applied. So maybe it's not a problem. Maybe it is. Again, depends, if you have a very small data set with some writes, not heavy write, like we have experienced in MySQL, it may happen that also in MySQL, you just have few seconds delay in the replication, and then all the data is moved over, and that's it. I don't know if actually there is this is something we may want to investigate a little bit.
Yeah.
Maybe in Postgres there is something like what was supposed to be in the semi-sync, which is the server doesn't go ahead in the transaction till the transaction is shipped and received. So also if a sync, you have the guarantee that the data is written in the secondary. So it will be eventually applied. So data inconsistency is just temporary, right? Because it will modify, it will be applied, so the data will be there. While in MySQL with fully asynchronous, you don't have this, and then you may lose real data, right? That's maybe is the only difference. I don't know. I am not a PG. If you want, I can ask my peer, and I actually
No,
tomorrow
I think we should.
tomorrow I will discuss with my peer, and I will
Because
come.
we should start this discussion between Mongo and PG also, and we should try to understand the nature of problem in these technologies too, because this is a very important problem, but I don't see this become discussed this much in Mongo and PG.
Yeah, I think that could be a great talk for another community office hours as well. The three operators discussing together.
Yes.
Since we're talking about asynchronous replication, what scenarios do you expect to enable in the future? Could I summarize what's it for that?
Well, for async, the async topology is handled by the orchestrator, a tool from MySQL community. So, as I said, the async replication works, the failover work and stuff, but it requires a more thorough testing. Also, we need to leverage the orchestrator features more to ensure this, especially this failover problems. And we need to allow users to at least be aware of this trade-off by showing them some both data and the solutions for them. Also, there can be some things that we can do that improves the failovers, not just trying maybe waiting for the secondary to catch up, but maybe we can interject in the process. This kind of stuff will require point time recovery to work in async replication and in operator also, because right now we don't have point time recovery. So we can think of this kind of stuff, but the main focus will be the failover process that makes both hard for users to shoot themselves in the foot and also help them when they need.
Okay, so Marco, I will vary a little bit the question for you, and we can talk about what is the immediate next step that users can look forward of seeing the Percona operator for MySQL with group replication now that is GA.
What exactly you mean by that? Sorry.
Yeah, what scenarios we are expecting to enable in the future for that? What's the next step after this GA?
For group replication.
Yep.
Well, the next step is to have users do the VL test, the production test. And we know, as usual, no software is perfect. And, nothing will come up without some problem. So we expect to get additional help from external community about this, testing it, telling us what is not working as expected, and telling us also what is working well, honestly. My expectation is to start to see it implemented in a different environment. And, we know that some of our customers are going to use it. There are also some solutions out there that are based on group replication that may benefit for it. Some sharding solution, for instance, that we know very well, that could benefit from this operator in terms of the automation and managing the specific cluster. So I'm expecting to see his adoption to actually grow quite significantly in the probably beginning of the next year. It is not going to be immediate. And we are here to help, and hopefully we will not get too many tickets. That's it.
No, more tickets is okay because it shows people are using it.
For you,
yeah.
not for the people in support, right?
Yeah,
They don't want to see ticket. Okay.
That's true. So
Yeah.
like we say PXC operator is battle tested. And by battle I mean real battles, not just okay we tested it. So we tested the operator of course, but it needs to see battles to become mature, of course. So and a battle cannot be a synthetic thing that in a controlled environment. It can be in a messy environment like production. So that we can really learn from the actual workload. So that's the thing. It needs to be battle tested. If people start using it, if people also like if you try to break it, it's welcome. It's always nice. People can just like maybe in a controlled environment, but they can try to break it in various scenarios. So we always like to see this kind of scenarios. Even if we cannot fix all the issues, it's better to understand the limitations of the tools. Because we want to present something real rather than the imagination for our community and for our users and the customers.
Agree.
So this is the thing. And about the roadmap, I can share some stuff. So the next step will be like we will be focusing on async and making sure it is ready for production. Also, we will be focusing on performance and performance auto-tuning. Marco had a lot of good stuff in this front, and we want to use them. We want to leverage them. So from out of the box, people can have a very good performance rather than trying to auto-tune the database themselves. There will be some backup improvements, like backup encryption, incremental backups that because of our backup implementation in PXC operator, we couldn't deliver these features. But in the new operator, in PS operator, we will be able to. And also this new MySQL operator helped PXC operator that we used a new backup design, and we are now moving it to PXC also. So there will be no change by default. It will be under a feature flag, but people will be able to use this new design of the backups. And this will allow PX operator to use backup encryption or incremental backups also. This will be helpful for PXC users as well. Yeah.
Yeah, we are near to close this conversation. Thank you both for sharing your insights and for the work behind this release. Before we wrap up, Marco, Ege, do you have any last words or a final message you would like to share with audience, with our community regarding GA or the new operator?
I have one thing. Go for it.
So like we love to hear from our users because like our customers has channels to reach us, but our users also has. So we have Percona forum. We are very active there. So if you have a question, please, even if it's just a question about you are not sure about something, you can ask something there. If you have any problem or again a question, you can create an issue on GitHub. We are like monitoring our GitHub issues as well. If you like, you can create a ticket on Jira. If you have any problem or a feature request, an improvement request, they are very welcome. Also, like if you want to get your hands dirty, you can create a pull request for us. We review them, we give feedback, and if it is, of course, useful for all users of the operator, we accept them. So you will get attention for sure if you create a pull request. So please reach us from these channels. So your voice will be very appreciated.
Marco?
Good, great. I have to say just one thing. It is very important to keep in mind what Ege was saying. Kubernetes operators are not based on magic. So there are some physical law that needs to be respected, that people can, whenever they approach and start to implement this product as any other thing based on Kubernetes, they still have to respect some specific restrictions. So do not expect to have the magic wand in the hand. They will work and they will do their job, but still you have to do yours. So, and set the right expectation to whoever is your manager and whoever is your boss, because otherwise it will never work and you will never be successful.
Mhm. Yeah, agree with that. Again, thank you so much, both. This conversation has been very insightful, not just into the technical journey, but also into the vision behind what we offering new options for our community. For everyone watching this conversation, this video, thank you for tuning it. We strongly encourage you to dive into the Percona Operator for MySQL, also Percona XtraDB cluster. We are sharing all the necessary links in the chat, so just feel free to visit. Everything is open source, and we will see in our next community office hours. Thank you so much for joining. Thank you, Marcos. Thank you, Ege.
Thank you, Edith.
Ciao. Bye. Bye.
Bye.
Bye.